This is the third part of the video. Now, in the second video, we told PixInsight to integrate all our images. So let's see what it has done. Now we can just get rid of this. That is just the log, process log. Now, even after caching all the files, it took around 3 minutes to process, which is okay. So I'll just get rid of that. Rejection high, rejection low. Now, rejection high and rejection low, that would be any you would see any rejection frames there. So I'll just click that, and that's our final image. Now, a lot of people would be disappointed when you integrate your image and the final image you see is really dark and you can't really see anything. Now that's because the image is in linear state and the data is already in there. All we have to do is stretch the image. So if you spend a lot of time, stack your images and end up with a really dark image, don't worry, that is just normal. Probably be the same for all the users who are using Deep Sky Stacker. So at the end you will see a really dark frame. So what you just have to do is save that as a TIFF file, pull it into Photoshop and add a curves adjustment layer. That will help you stretch the image. Now, just to see what we are going to process, I am going to apply an auto stretch image. Now it's only a screen auto stretch, so it's not actually applying it to the image, it's just for visual reference. So I'm going to go Process Explorer and go Screen Transfer Function. And well, if you come on Screen Transfer Function for the first time, you'd probably see this checked. So just click there and uncheck it, and you go click on this auto stretch function, and that's it. That is the Large Magellan Cloud. Now that is the image we will be processing. Now, first things first. Now, because it's in linear state, we use all the mathematical functions to either reduce noise or extract the do a dynamic background extraction, so or any color corrections. So once we've happy with all those, we change the image to a non-linear state. That means we actually apply all our histogram changes and screen transfer function to the image. Okay, so that is the image we are looking at. And so first things first, we go into Process and go Background Modelization and Dynamic Background Extraction. Now, what dynamic background extraction does is it will go through the image and it will try to see if the image has a gradient. If it does, it will try to remove it. Now, this image looks really good. I don't really see any strong gradient, but we'll still apply dynamic background extraction and see what it does. Now, the trick is you apply your reference points onto the dark parts of the sky. So basically you're telling the software, okay, this is the background sky and this is where I want the background to be extracted from. So you usually avoid any places which are rich in dust, so any areas in here, or if this was a nebulae, you would probably try to avoid any nebulous regions. So I can see there are a few nebulous regions around here, the Tarantula Nebula. So yeah, I would just avoid any of those regions and try and stick to the dark places. So usually around 30 to 40 samples should be okay. So I will go ahead and place all those points and be back. Okay, so I have placed all my sample points. Now, as you can see, I've mostly placed all my points around the corners. Now that's because I don't want the software to get rid of any of that glow or any of that nebulosity around those places. So once you've done that, you go under target image correction, you go subtraction. Now we're using subtraction because we want to get rid of the gradient. If we were to get rid of any vignetting, we would go division. Well, from the image, this looks like it's a really good image, and there's no significant vignetting going on, so we'll just stick to subtraction. And then you can just check discard that background model and replace target image. Now what replace target image is going to do is it will replace your current image. Now I suggest using that because it still keeps your history, so at any point you can go back into history. If not, it will create a new image, and if you delete your original image, you can't go back into the history. And what discard background model does is it will just delete the background that's been extracted. Now, because I want to show you guys what the software is actually extracting, I'm going to uncheck that and just click on this green check. Now it's going to go through the whole process of extracting the background, which is pretty quick, and it's going to return us the background. Now, as I told, it's still in linear state. The extracted background is in linear state as well. So you just go Control A and OK. So you can see it has removed that parts of vignetting there, and it had a slight gradient which it did remove. So it has subtracted this from the original image and making it look a lot better. So you close that. Now hang on, thought that it was supposed to make your image look better. It actually did. Now remember, we still have a screen transfer function turned on, so all you have to do is go back into screen transfer function and click that nuclear button again, and it will show you your image again. Now you should see there's a significant difference in the corners. Now I hope I can show that. Okay, so that's previous and that's next. Now there's not really a significant difference that you can see on the screen. Not sure if you can see in the video, but there is definitely a difference on my screen. Okay, so that was the first steps. Now from here on, we will proceed on to background color correction and just a basic color correction. So that'll be in the next video. Thank you.